Hello, rocket builders. So by now you've noticed that we have models for the Saturn V. Well, what I'm going to talk about today is how to assemble this into a final product. Stay tuned. Remember folks, I've been certified to build and fly rockets up to level 3. If you don't have these qualifications, you might want to consider a simpler project and perhaps join one of your local or national organizations. Rocketry is a very safe hobby if you follow some very simple guidelines. Okay, so you've downloaded the models and started printing. One of the things you will notice is that so far the only models that are available are for the command service module and the tower launch escape system, as well as some smaller parts for the reaction control thruster quads, which is running away from my fingers. There we go. And for nozzles for the launch escape system rocket motor. Okay, so what I'm going to do today is tell you how to put these together. Now, the first thing you're going to have to do is ignore the quality of these prints. As you can see, it's really not good. Now, I have some known issues with my printer, that's part of it. I also have been using some really old PLA, which has been in storage for the better part of 2 years. I have some new stuff arriving today, so hopefully we'll get some better prints shortly. Certainly as I print with other filaments like PETG, it works well, but PETG doesn't glue or paint well, so I'm going to go back to the PLA. Okay, so caveats aside, where do we start? Well, we start with the launch escape tower. Okay, so this is actually the one I printed in PETG, and you can see it is actually a lot better quality than what I have in the PLA. So yeah, let's put that aside. It looks good, but it's not what we want. Okay, what you will notice underneath is that there are 4 holes, and you're expected to print 4 of these nozzles, and they would simply glue in to each of those holes so you have a quadrant of rocket nozzles. For PLA, the best glue you're going to get is going to be what's known as a CA glue, cyanoacrylate, which is known by the trade name as super glue. And you can get various versions of this in your local hardware store, even in your local drugstore. You are going to get better quality versions in your local hobby store, and you really don't need much for this. So it is expensive when bought from the hobby store, but it is quality stuff. Okay, so you would start by gluing those 4 into place. Now, in terms of printing this, you have some options. I printed this with a light infill, but you could even print this with no infill as long as you have probably about a minimum of 3 layers in there. And that'll keep it nice and light, which is important because it's going to be balanced on this tower. And this tower is really well designed. NASA scientists actually knew what they were doing, go figure. So it can take a lot of stress, but it is still a pretty flimsy plastic part. So this is the piece you're most likely going to have to replace as you build a flying model rocket. Okay, more on this in a moment. Okay, so 4 rocket nozzles glued into place. Now, I recommend taking your time at this point. Even CA glue has a curing time, and if you try to accelerate it a little too much, you know, pieces are going to fall out. Now, you can get a CA accelerant, which causes CA glue to cure significantly faster, and you can try that. It's not something I use myself, I just give it time. So, whatever works for you. Okay. The tower. This is a bit of a torture test for your 3D printer. It is a pretty intricate design. As I mentioned, NASA scientists really designed this well. This was built out of tubular steel on the real one, and it handles stresses in a lot of different directions, including rotational stresses, which is what this big ring in the middle is for. Now, if you've tried building one of these out of dowel or anything like that, you will know that it is a pretty tricky thing to make. And it is actually a very good application of 3D printing. When I built it for my 1/22nd scale model, which was the original design, it came up like this, and this thing is pretty solid. I've had impacts on the launch escape system, and the parts for the launch escape system failed, and the tower has yet to fail. So it is pretty good. Now, even though it's probably going to do so at this scale, I recommend printing this solid. Like I said, this is a relatively flimsy piece compared to the rest of it, so you want it as solid as possible. Now, this is the size I originally designed everything in. This was for a larger Saturn V model that is already flown. And as I got into modifying it for this project, I noticed that it just was more work to scale it down to 1/53rd than to keep it in the original scale and scale everything when it was done. So that's what I did. Now that's important here because one of the features for the original is for the launch escape system tower, I have some pegs at the top which fit into these holes. Now, it works well at this scale, okay? Things fit in quite nice. When you get down to this scale, the tolerances are a little tighter. Those holes are a little bit too small. On this scale, I can go in and dig them out a little bit wider, but on this scale, you just wind up injuring stuff. So what I did instead, when I assembled this earlier, is those little posts on top of the tower, I just took a pair of snips and removed them. Now, it's still good to have those as guides so that you can guide it into place and orient it correctly. Again, a little bit of CA glue works well. Give it time to cure before handling it or moving it. And yes, CA glue does need time to cure. Okay, so at this point, things have been pretty independent of orientation. You can't really assemble it in the wrong order, okay? But there are some features on the launch escape system which make the next step a little more critical. Not overly, but just a little bit. Okay, so if you look at this, you'll see that there's a couple of cable raceways going down on either side of the ejection motor, okay? That only happens on one side of the launch escape tower. When you are placing your tower into your capsule, okay, you want to have those cable raceways on the same side as the doorway to your capsule, okay, which looks like that in case you have problems recognizing it from the model, okay? So that's where the astronauts went in and out of the capsule as they're being launched. Now, you may notice too that this looks a little different from some of the photos of it flying in space, and that's because there's actually a fiberglass cover that protects the capsule during launch, which flies away using the launch escape tower once they're successfully underway. Okay, so it looks a little different both during and after. The service module itself, however, does look the same. Okay, so the one thing that isn't on the service module, there are some surface details that are there, such as the antenna and so on, but the reaction control system quads really stuck out enough, and there's enough detail on them that it wouldn't really translate well if you were trying to print it directly on here. So what I've done instead is I've left some holes in there. You would print the quads separately, okay? And they have a post that fits into the hole. Okay, now you will notice that there is one side of the reaction control system that's a little bit longer, and that is meant to be oriented in the vertical direction. That's it. So with all that done, you've now assembled the Saturn V, the Saturn V capsule. So Apollo 11 in this case. Okay, so we did see how orientation was a little bit tricky for the launch escape system. To keep things easier going forward, I've actually put a little key tab in the capsule, and that will have a corresponding key tab in the service module, lunar module adapter, also known as the SLA, so that things will be correctly oriented as we go through. And as we do each piece going down, it'll have a similar notch and tab arrangement. So everything will be oriented correctly. Okay, so what I printed here are some actual test pieces. They obviously have no details yet. These aren't even completely correct because they were, like I said, test pieces. But I will have versions that have those tabs in there. If you want to print these out as you go along, you will be able to. And this will allow you to check for size, for fits, and so on. And as we add details, you can replace pieces going down. So while you do want to start gluing some of these pieces, you don't want to start gluing all of those. Now the other thing to be aware of is painting, finishing, and so on. So my primary reference source is a set of diagrams produced by a company called Real Space Models, drawn by a guy named David Weeks. Links below. So those are copyright items. I am not going to be photocopying those and putting those online. But the painting is going to be pretty simple, and I will just draw up some simple diagrams that will show you how to do that. Now I'm not going to be painting this right now for many reasons, including these are still bad prints. It's Canada and it's still winter, so it's not exactly painting season yet. So yeah, there's a lot of reasons why I don't want to paint right now. But as I do that, I will certainly update the videos as well. So in terms of what I'm working on right now, the model for the command service module, the tower, the launch escape system is pretty much complete. So from here up, we're done. You can go ahead and start printing things. That doesn't mean I won't reserve the right to change things in future as details. I mean, I already know there are some subtle changes I'd like to make here. I'm not sure I'm going to be doing that for a long time, so you're probably safe, but I do reserve the right to do that at some point. This is reasonably accurate in terms of scale model, but like I said, there are some minor discrepancies. One of the things you will also notice if you go at it with a micrometer and things like that is I have had to exaggerate some details so that they will just show up a little bit better. In particular, the seams of the joints along the service module, they're probably a little bit bigger than actual scale, but you wouldn't see them otherwise. Okay. So I have taken a little bit of artistic license as I go through here, but I've tried to minimize that. Okay, so where do we go from here? Well, at the moment, I'm working on adding details to the SLA section, and as soon as that is complete, I will publish not only the SLA, but also the boilerplates I've done for these sections, so that if you wish to, you can print these as well. And they will have the proper tabs and slots so you can fit them all together. Right now I'm working on the diagrams for the Apollo capsule section, which covers everything really from the SLA up. They were common between the Saturn 1B and the Saturn V, so I already had those diagrams. I'm waiting on the full set of diagrams for the Saturn V. So the Saturn 4B stage, which is this section, was common between the Saturn 1B and the Saturn V, but there are some small differences. The auxiliary propulsion unit, for example, is a little bit different on both vehicles and so on. So I'll work with what I have, but I expect to have some major changes when I get the Saturn V diagram, so I won't be publishing those for a while. This is an ongoing project. This represents several hundred hours of model development. The capsule alone is actually quite complex. So it's going to take a little bit of time. I've got a lot of the pieces that go on here, but again, I need to see it in its entirety. Okay, so that's it. There will be more in this series. As I get the models for the SLA developed, like I said, I will publish those on the Thingiverse site as well. So bear with us. It's going to be a long-term modeling project, but good luck. And as you print pieces, send me pictures. I'd love to see them. In the meantime, happy flying.